Good day everyone. In this video, I will discuss to you how to find the center and radius of a circle using a formula. In order for us to identify the center and radius of a circle, the equation of a circle must be in general form. So we have here ax squared plus cy squared plus tx plus ey plus f is equal to 0, where a, c, d, e, and f are all real numbers. And we also have the condition that a and c must be greater than 0, or it could be that a is equal to c. In the previous discussion, I taught you that we can easily identify the center and radius of a circle given the standard form equation of a circle. So because in this form, it's easy to identify the values of the center, which is h and k, and the radius. But for now, given the general equation of a circle, we will be using this formula. So there is a condition that this formula is only applicable to the general form wherein a and c must be equal to 1. So here is the formula for the center. We have negative d divided by 2 and negative e divided by 2. Take note that d is the numerical coefficient of x and e is the numerical coefficient of y. Now let us go to the radius. This is the formula for the radius. We have 1/2 the square root of d squared plus e squared minus 4f. D here is the numerical coefficient of x, e is the numerical coefficient of y, and f is the constant term in the general equation. Now let us apply this formula to our examples. For example number 1, we have to find the center and radius of a circle defined by the equation x squared plus y squared minus 6x plus 10y minus 66 is equal to 0. So let's focus first on the center of the circle. Here is the formula, and then let us solve for this. So let's identify first the numerical coefficients, the values of d and e. 1 because that is understood to have 1 as the numerical coefficient. C is equal to 1 also. D is equal to negative 6. E is equal to positive 10. And F, which is the constant term, that is equal to negative 66. Now we can substitute the value of D and E to our formula. Let us just substitute it here. So D is equal to negative 6, you put it here. And then E is equal to positive 10, then write it here. And then simplify this one further. Look at this first coordinate. We have negative 6 over 2, and we also have the negative sign there. So negative times negative, it will become positive. So 6 divided by 2, that is simply 3. Negative 10 divided by 2, that is equal to negative 5. Therefore, given the general equation of a circle, the center is at 3 and negative 5. Now let us move on to identifying the radius of this circle. Now here is the formula for the radius. We have 1/2 the square root of d squared plus e squared minus 4f. So we just copy the one that we have solved a while ago, wherein we have identified the values of a, c, d, e, and f. Then we will just substitute the value to the formula. So here, let us substitute the value of d. D is equal to negative 6, so you put it here. And then E is equal to positive 10. And then for the constant term, we have F, that is equal to negative 66. And then let us simplify this one by simplifying first the numbers inside the radical sign. So we have 1/2 negative 6 raised to 2, that is equal to positive 36. 10 squared is equal to 100, and then negative 4 times negative 66 is equal to positive 264. And then let's add all the numbers inside the radical sign. We have 1/2 times the square root of 400. Get the square root of 400, that is equal to 20. And then simplify this one further. We have 20 times 1/2, that is equal to 10. Now that we were able to identify the center and radius of the circle given the general equation, here is the center and the radius. This will be our conclusion. Therefore, the center of the circle is at 3 and -5, and radius is 10 units. That's all for today. Thank you for watching. I hope you learned something. If you haven't subscribed yet to this channel, please don't forget to subscribe and hit the bell button to update you on my next video.